Hi, in this video I will be presenting on a project that I've been working on. It's an AI interface for the Hawaii Climate Data Portal. This is the opening page when you first start up the application. So it tells you what this chatbot is able to do. It gives you some examples of queries that you can ask. So this one, if you click on it, you can map the latest statewide wildfire ignition risk and look at the highest risk leeward zones. So it puts it down here in the chat box, and then you can edit it as you wish. You can add, um, you can tell it to make a chart of something, whatever you want. Um, but since this is a live demo, I went ahead and I have some, I have a conversation that I already asked some questions. That way we don't have to wait because each query could take anywhere from 1 minute to maybe 5 minutes, just depending on how difficult the query is. So just to begin, uh, so here's the first query that I asked it. What are the 10 driest stations for this month? So it goes through, the AI works step by step to understand, okay, so find the driest mesonet stations for June 2026. Um, Looks at the average daily rainfall rate. It will sometimes notice, like, for example, here, there's a near zero reading, so maybe that's a failed gauge. It points those things out as well. And then it gives you the table. These are the 10 driest mesonet stations for June 2026. It gives you the station name, which island it's on, how many days it's been reporting, the average daily in millimeters, the month total. And then if you want, you should be able to download this table as a CSV file if you want to do further analysis on your own. Um, Also, if you want to add this table to the next query, you can click on this Add to Context button. You can select the whole table, or you can select um, a few stations, and then it gets added to the context, and you can ask another query. But we're just gonna not do that for now. So in addition to the table, it tells you some extra, it gives you an explanation. Um, it gives you two caveats for this query. Here's another query that I asked. So I wanted it to quantify the rain shadow on the Big Island, sample the long-term annual rainfall climatology at Hilo and Waikoloa Village, and tell me the ratio. So it did that. It worked step by step. It provides narration here. That's the bolded part, and then it also does have some in-between steps that you can look. You can click on this arrow, and it will tell you um, more in detail what's going on underneath. Uh, so here's the ratio, the rain shadow quantified. So it's 13.1 to 1, and then it tells you that 13 X contrast over the 30-kilometer distance is one of the steepest rainfall gradients anywhere on Earth. Uh, and those values are coming from the 1991-2010 legacy rainfall climatology. So that's that query. And then here's another query. Uh, this one is for the Big Island, compute the monthly rainfall anomaly for each month of 2024 relative to that normal, plot as a bar chart. So uh, it did work step by step, and it did produce a chart, which I believe is right here. This is the Big Island monthly rainfall anomaly. So according to this, let's see. So January through March were all negative, opposite when Big Island usually banks most of its rain. And then the surplus was concentrated in one dry season, which was in August. Okay. And another query is compare statewide rainfall in January 2014, the strong El Nino winter versus 2018, which was near neutral. Show those maps side by side. So I did produce the maps. You can click here to open the maps. And then if you want to more easily read those maps, you can click on that pop out button, and it should load them. And here you will see, I believe this means that with between 2014 and 2018, it looks like some parts are showing more yellow. So that means that those were drier. And then this right here, the Hilo side of Big Island, where my mouse pointer is, that means that it became wetter from 2014 to 2018. Okay, so we can close this and go back. It gives another explanation. Okay, and then I ask this query, are any areas at risk of drought in the coming days, weeks, or month? So it looks at cumulative rainfall over the last 3 months. It looks at current moisture, and it uh, looks at Molokai, Leeward, Maui, uh, looks at the driest stations over the last 60 days, and the lowest soil moisture sites. Since this is a forecasting question, it does give a disclaimer. So these are the uh, areas most at risk of a drought. It gives you a table. These are the stations. And then it tells you, so Leeward, Maui, Molokai, and Kona side of Big Island, these are most at risk of a drought. And then it tells you the three signals as to why it thinks that way. Yeah. And now another query is which areas of Hawaii have the highest wildfire risk right now based on rainfall deficit, soil moisture, and dry season vegetation? So it concluded that the highest wildfire risk right now is Leeward Maui, Lahaina, Olowalu, um, Leeward, Big Island, and Molokai. Um, so these are the factors that it looked at: soil moisture, fire weather. So it looked at the HCDP ignition data that we have. Looks like it also compared the rainfall deficit versus the normal. Okay. Um, I asked it to show a map of the current soil moisture across Maui and Big Island. So we can go to, yeah, so we can click here. So this is Maui, the Maui ignition probability map. It generated this. And then here's the Big Island one. Wow. Oh, and okay, yeah, and then these stations have the driest soil moisture according to the result. This was a longer query. I just wanted to test out what my AI interface can do. So it looks at September of 2000, 2019, 2025, and it compares the statewide mean air temperature for those 3 years, and it shows 5 maps. So that's going to be here. So this is um, September of 2000 right here. It's probably better if I pop this out to a new window. So this slide bar down here allows you to change between 2000 to 2019 and 2025. And then the second map that um it did a um it did some back end calculations to generate this map, which is 2025 versus 2000. So red equals warmer than 2000. So, for example, here, this is Big Island. We can see um, maybe at these points. Um, yeah, so at these, I guess these are the volcanoes. So the temperature was warmer in 2025 versus 2000. And just while we're here, you can increase the opacity of the layer. You can also download this GeoTIFF. You can plot the stations, the Mesonet stations on the map. Uh, yeah, that should be all of that for now. This is just more tables and data that it found and collected and an explanation. Uh, Interesting here was that September 2019 was an anomalously warm month. Um, hmm. So then I asked a fun query. So where are the most ideal places to grow coffee? Uh, it's a climate suitability problem. So it tries to find data that can answer that question. I believe so it looks at annual rain, the coffee belt elevation, um, an approximate temperature. Uh, yeah, it gives a table of the regions that coffee would grow well. These are like the top one, two, three, four, five, six. It even has like a why it works section here. And again, this can be downloaded as a CSV. Here's a further explanation talking about the rainfall, and it has to be a mild frost-free temperature. Yeah. And then I did another forecasting kind of query, and this one says do an extensive analysis of previous years with this year's climate and try to forecast how the weather will be for the rest of the summer. Is this summer on trend, or does it look like it will differ? And it gives the disclaimer, which is right here, and then it does answer the query. So it says most of Hawaii is heading into a summer wetter than normal, not drier. So it talks about that. It says June 2026 is running roughly double recent Junes. Temperatures are near normal. Mostly on trend with two departures. These must be the two departures. Let's see. Says it'll be a fairly typical on-trend Hawaiian summer, just maybe a little bit wetter statewide compared to 2023 through 2025. And yeah, so after at the end of a query, I don't know if I mentioned this earlier, but it does give three suggestion queries. This one the first one typically closely aligns with that query. So you can click on this and then it will start answering the query. I suppose while it's doing this, I can show uh, yeah, while it's doing that, I can just quickly show this new feature that I'm working on. It's a tab called My Agents, and this essentially allows you to create like a watch list or a monitor. So you can do the station watch. You can watch certain stations. Um, so this one watches seems like these three stations overnight, and it looks for rainfall or temperature, and it wants to know, does anything unusual happen versus the seasonal norm? This one's a Maui fire risk monitor, so it overnight it's constantly, or every 6 hours, it's monitoring the wildfire risk on West Maui, uh, specifically Lahaina through uh, Ka'anapali, and it tells you if there's a fire weather condition that's getting dangerous. And then if you want to, as the user, create or design your own watch list or agent, you can tell it to monitor the station. Let's monitor the stations. Let's say monitor the leeward stations on each island and uh, be on the lookout for anything that uh, might depict fire, that might reveal risk of fire, something along those lines. You can select all of the islands that you want it to focus on. You can choose, if you want to, you can choose which, these are all of the stations. You can, if you want to be more specific, you can, these are the metrics you can track. I already mentioned in the prompt what I wanted to do, so I don't necessarily have to click all of these. Um, you can choose when to flag it, and you can choose how often you want it to report. So it can be live or every 1 hour to 6 hours, etc. You can also name the agent and then create the agent. This is a feature that I just recently started working on, so it's not quite working. Um, but it's something that I'm planning to implement and continue working on um, for the rest of the summer. So I believe we can go back to the chat and see if this has completed. So, so I did do the most recent 3-month SPI drought versus surplus, and for Big Island, that seems to be what it's looking like. Sometimes when I'm zooming at it will sort of be a little bit buggy, but that seems to be what it, yeah, that's the map that it wanted to show me. And then it gives, here's the textual explanation. Um, I would say in general, the textual explanation is a little bit more accurate than the map, just because I'm still working on the map and how it displays the geotiff rasters of different uh, sets of data. Yeah, and I think this is where I'll end this um, video demonstration of my AI interface for the Hawaii Climate Data Portal.